This video is going to take a look at some various issues with triangles, like triangle sum theorem, where we can take all three angles, add them together, and get 180 degrees, or situations like what you see down here, where we know, say, two interior angles, but we don't know an exterior angle. So we're going to take a look at a few of these problems, see how they work, and hopefully help you work through these different problems, the algebraic ones, more simple ones, in hopes that you'll do well with triangles. So take a look. Let's look at problem one here, if we can get it in focus. We know three angles. We've got 100 degrees, we've got 25 degrees, and then we've got x number of degrees. And what we're trying to do is figure out that x. If I take all three angles and add them together, we should get back to 180 degrees every single time. And if you want a proof for that or a reason why, we can take a look at that in another video. The purpose of this one is just to show you how to do it, not so much why it works. So if we know that all three of these together are going to add up to 180, then what we can do is take these two angles, add them together. So in this case, if I take 125 and add them together, we'll get 125. And then what we can do here is simply subtract. So if I have 180 degrees in total, and I know 125 of them, all I have to do is subtract. So in this case, if we take our 180 and we subtract our 125, you should end up at 55 degrees. So there we are, 55 degrees. Not a big to-do, right? Or a problem like number two. It works exactly the same way. It doesn't matter that the variable's been named different. We know there's 180 degrees total. We've got 15 degrees here and 25 degrees there. So if we add that up, we should get to 40. And all we're going to have to do is subtract. So if we take 180 and then subtract 40, we should get 140 degrees is our missing angle. All right? So to write those answers, we could write them like this. We could say the measure of angle x is equal to 55 degrees, or in this case, the measure of angle y is equal to 140 degrees in that case. All right? But what about these algebraic ones? Notice here we don't have just one variable, we've got multiple variables. Or we've got a variable and then we've got a constant that's being added or subtracted, as the case could be. Aren't those going to be more difficult? And the answer is no, they're not. Take a look. If I take these three angles, and it doesn't matter that we don't know what they are, but if I take A plus 2A plus 3A, I already know what it's going to equal. 1, 2, we've got three angles in a triangle. Regardless of what they are, if we add them together, and we'll just mark over that 5, if we add them together, we know we're going to get 180 degrees every single time, no questions asked. So it's just a matter of solving this equation. Well, if I have 1A plus 2 more A's, that's 3. So if I have 3 A's here plus another 3, that's 6. So we have 6 A's equaling 180. And to figure out what A is, we'll just simply divide both sides by 6. So in this case, we'll get A. And then in this case, 18, I'll just ignore the 0. Here's a shortcut for you mental math-wise. We'll just look at 18. 6 will go into 18 3 times, and then we'll just bring that 0 down. So A in this case is worth 30. So we could say that this is 30 degrees. If it asked you to find the other angles, we could do that just as well. 30 times 2 is 60. And then 30 times 3 is 90. Notice this angle, though, does not appear to be right. And the reason for that is not all drawings are to scale. Notice in these top three, all these drawings are the same. But notice in this case, we're told that this is 55 degrees, and in this case, that's 15 degrees. And they're drawn the same way. Or in this case, we know that this is 30 degrees. Odds are that B is going to be different. Just because it's drawn a certain way doesn't mean we're going to use our eyes and say, oh, yep, that's exactly right. Notice, there's 100 degrees, there's 138 degrees. They're the same, at least the way they're drawn. But we know they'd have to be different if we drew them accurately. So not all drawings are to scale, so don't let your eyes fool you. In cases like this, follow the numbers. All right, let's do one more. So if we look at this one here, we know we've got B plus 2B plus, what is this, B plus 16. And we know that all three of these together is going to have to equal 180 degrees. All right, so let's look back. I've got 1B plus 2 more, that's 3. Plus 1 more, that makes 4B, plus 16 equals 180 degrees. Now, in this case, we've got a two-step equation. So I'm going to subtract the 16 first before I get rid of the 4. Now, in this case, we could divide everything by 4 if we'd like, since everything in this case is divisible by 4. But I think it's just going to be easier to go ahead and subtract. So we'll take 4b here, because 16 minus 16 zeroes out, and we'll subtract 16 from 180, and that should get us 164. And then we'll divide by 4, as we said. And again, mental math here for you. 4 goes into 16. We'll forget the 4 for a minute here in the 164. So 4 goes into 16 4 times, and 4 goes into 4 once. So in this case, we've got 41 degrees. And then here we've got, 82 degrees once we multiply 41 by 2. And then in this case, what do we have? 57. And again, the problems here didn't ask us to find all angles. It just asked us to find the variable. But just to show you, we can find them all. All right. Well, let's look down here at these last few, and then we'll call it a day. For number 7, notice, while this is a triangle situation, it's kind of a red herring. That's a straight angle. All straight angles add up to 180 degrees. So if I take the 72 plus whatever angle G is, I should get back to 180. So one way to write this problem out is G plus 72 equals 180. And then all we have to do is subtract that 72. So in this case, G equals 108. So 108 degrees. All right? So any problem like that will work. So for example, 7 works that way, 9 works that way, and 9 is not any different. Again, J plus 56 equals 180. So I've got 2 J's there, plus 56 equals 180 degrees. Now notice this problem set up kind of similarly to this other problem that we just worked out. Notice it's a two-step. We can subtract the 56, just like here we subtracted the 16. However, notice 2 will go into 56 and 180, so we could also divide everything by 2. So let me show you how that works if you do have, say, 3 numbers, and the number that you need to divide with can go into all of them. So in this case, I'm going to divide everything by 2. So divide by 2, divide by 2, divide by, whoop, there we are, divide by 2. So we'll get J plus, I need half of 56, so that'll be, 28. And then half of 180, so that'll be 90. And then in this case, just to find what J is, we'll subtract by 28 on both sides. So J equals, let's see, what would that be, 62? And there we are. So again, you don't necessarily have to subtract 56 first and then divide by 2. We can divide by 2 first and then subtract the 28 when we're done. All right. Well, let's look at number 8. Notice 8 is a little bit different. Our angle that we know isn't right next door. So here's what we've got. These two angles, this 32 and 63, these are called remote interior. These are remote interior angles. This one obviously is exterior. It's on the outside. And here's the neat deal. 63 plus 32 plus whatever this angle is, and we'll call it question mark for now. If I add all 3 of these together, we'd get 180. So let's write that down. So 63 plus 32 plus the angle we don't know equals 180. Well, here's a neat bit. H plus what we don't know, notice they're on a straight angle here. That's also 180. So let's write that out. So H plus what I don't know is also 180. Well, I want you to look at that very carefully. They both add up to 180. They both add this angle we don't know. So that means they're the same until we get here. Even though they look different, these two parts have to be the same. 63 plus 32 has to equal H in order for the rest of these equations to work out. So what we know is we can take the remote interior angles, we can add them together, and that will give us the exterior angle measure. So let's try it. So if I take 63 plus 32, let's see what we get. Well, 60 plus 30, so that's 90. 3 plus 2, that's 5. So that means H has to be equal to 95 degrees. And indeed it is. So if I wanted to look at something, say, like 11 here, if I add the 28 and the 88, that'll give me what angle E is. So in this case, the measure of angle E is equal 228 plus 88, so that would be 110 degrees. All right. What about a situation like this? Notice what I'm looking for is now not the exterior angle, but one of the interior angles. Well, that doesn't really change anything. Again, 42 plus whatever angle D is going to equal 147. Again, these two remote interior angles added together equal the exterior. Well, that's just a one-step equation. If I got to figure this out, I'll just subtract 42 on both sides. So D equals whatever 147 minus 42 is. And in this case, we'd get 105 degrees. All right. So that gives you a video on some just basic triangle work. Hopefully it helps. If not, come see me in the mornings, and I'll be happy to go over it with you.